In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision,
All right, Toby, Shane, we are live, gentlemen.
Yo, welcome to Aether Cosmology Roundtable number 38. Tonight, Shane is going to be giving a presentation on meteors, or really going to be leading a discussion about meteors. I think he has over 100 slides, though, so should be a lot of content. So, yeah, without further ado, we kick it on over. Shane, go ahead.
Beautiful. Thanks, Toby. Beautiful introduction. You're getting like to be a professional MC at this point. Speaking of rap gods. Dude, so yeah, let's speak of last week's style, right? Open roundtable sort of contributions. Everyone wants to have a question. I mean, we don't need people coming in and interrupting to tell us about the day, but if you have an on-point topic, question, relevant, anything, I would say let's go ahead and shout it out. So let me get my stream situated nicely. There we go. And we can start her off. So here we go. Meteors. Right. We're going to go through definitions in just a second, but you got a whole bunch of things that are happening in the sky that people frequently confuse with each other, right? You got meteors, meteorites, comets, asteroids. So meteors, right? These are the streaks of light, shooting stars, caused by whatever they think is entering Earth's atmosphere. Source: small particles or fragments from comets. So there's no substantiation, doesn't have a rock. You're not going to go find where this hit when you see a shooting star, right? Technically, according to this, doesn't exist. It just hits and just poof. Doesn't exist, poof. It's just a light in the sky, literally a light in the sky. Then you have meteorites, these bigger ones, right? A meteorite would be what killed the dinosaurs, right? A city-sized meteorite came in and hit in the Yucatan Peninsula, whatever, South America, and caused widespread devastation a bajillion 23 million years ago, or whatever. Yeah, of course. That's this boy right here. Meteorites, right? And they survive the journey through the atmosphere to land on the surface. And they come from everywhere. We'll get into that briefly, but they come from all around us everywhere because space. Then you get comets, which are just returning bodies right from the outer regions. They're on there. They say they're on their ecliptic, so they have an orbit. We see them periodically with great variation in the reoccurrence. But we're not going to talk about those. We're not even going to be talking about asteroids, but we are going to talk about them a little at the beginning to disqualify them, right? These things that orbit the sun, that are in space, that never hit the Earth, that nobody can ever verify, that literally amount to specks on the black, and they just they're essentially stars that they're labeling, right? Leftover building material from the formation of the solar system. Sure. But since we're on cartoons, let's take our science from this super heliocentric globular cartoon.
Hurtling towards Earth, a shooting star catches the attention of anyone looking up. But where does it come from? Out in the solar system, asteroids, comets and planetary fragments can move into Earth's orbital path, pulled in by gravity. As basketball-sized meteoroids approach Earth's mesosphere, frictional heating burns them up, producing the impressive light show of a meteor. These small meteoroids never make it to Earth's surface. Scale up to car-sized meteoroids, and these rocky bodies power through the atmosphere, burning but leaving enough behind to deposit a meteorite on Earth's surface. Yet to produce impact craters, meteoroids need to be much bigger. House-sized objects, expelled from the asteroid belt, will enter Earth's atmosphere with a literal bang. The sonic boom can be heard for miles before the meteoroid strikes the Earth, compressing the ground. Kinetic energy is transferred into shock waves so powerful that the projectile and ground beneath can vaporize and melt. A transient crater is excavated by complex interactions between tension release and shock waves. whilst impact ejecta can be expelled past the crater rim. Other material remains in the transient crater to later become crater fill impactites. Modification following large impacts sees central uplift of the crater floor and collapse of the unstable crater walls. Faulting continues far into the future, alongside hydrothermal activity, which changes the mineralogy of impact site. Earth has 200 known impact craters, a fraction of the 30,000 on the Moon's surface visible from your backyard.
Yeah.
Volcanism,
Yeah, we'll touch on all that.
erosion, and the atmosphere all help to disguise Earth's past meteorite impacts. Yet the Chicxulub crater is a scar from an impact 66 million years ago, an event so devastating that it wiped out over 60% of life on the planet. Tsunamis, earthquakes, and forest fires followed, which inhibited plant photosynthesis. Atmospheric dust and temporary global cooling occurred due to nitrous oxide released from pulverized rocks. But from devastation, life blossoms. Shocked rocks have increased porosity, helping microbes to colonize this biological niche. Crater lakes and hydrothermal springs provide unique, protected hotspots of evolution. And meteorites themselves bring carbon to Earth, an essential building block for life. There are economic benefits too. Canada's Sudbury crater houses some of the world's
Dude.
largest copper and nickel.
Because there's no
deposit.
carbon on Earth, right? So we need some space.
Dude, okay. So they're attributing all this that we're finding on the ground to things that impacted from the sky, and based on where it landed geographically, this place is now rich in minerals economically, and they can export their meteorite metals and shit. Is that kind of what they're putting forward?
Yeah, because that metal grew like bacteria once it hit you.
Okay, just making sure.
Honestly, I didn't even hear that the first time, the carbon bit. I just heard it now and burst out laughing on my mute. It was like, we didn't have any carbon until... Okay, it's fine.
Hydrothermal fluids have taken advantage of pathways created by faulting and fracturing of the impact crater to concentrate valuable resources into metalliferous ores. Similarly, oil and gas can migrate along these pathways, creating important hydrocarbon reservoirs.
Meteorites bring dinosaur juice and channel all that, I guess.
Studying impact craters is essential to understanding the frequency, consequences, and value of meteorite impacts to better prepare for them in the future.
Oh, man, that was such good propaganda. I got my good dose of it. But it kind of explains their whole position without any nuhs. And like they even went into depth on how the compacting impact forces would create those visible signs that that we can't see on any of these. Turns out.
I could feel my IQ points just floating away.
It's like, yeah, that makes sense if you don't look into anything else after this. If you walk away with that as a sum total of your knowledge, you're like, yeah, sure, I know what meteors. Or what, you stupid fluffer, you don't know what they are? Idiot. Right? Like I know from my cartoon lore that I just learned that they brought carbon to the Earth. Stupid. Anyway, here's a bunch of the pictures, right? When they say we hit craters, it turns out most of these before 1960 were called other things, were well known as other things, were all well known as the same thing, right? They were just like, oh, they were geysers. They had just well known sinkholes. They had issues. They always fill up with water. Right? When it's like, well, that's all the meteorite changed the chemical makeup. That's what the video just said. And it's like, or if they were geysers, that would probably also happen. But they also mentioned the moon. Everyone likes to, they said there's 30,000 on the Earth. And we're going to map those out and compare where we think those spots are. But then they said there's 200,000 on the moon. So let's take a look at the moon. All right, they always say those are all perfect impacts. Nothing ever glanced. There was no glancing blows here. It hit 90 degrees perfect every time.
And nobody's ever plotted a new one.
So you don't see those little
Yeah, no one's ever seen a new one happen, actually. They are pretty open about that.
moving around.
There's that also video of the moon, not only the lunar wave, but like looking like plasma, and then they were just bubbling plasma in an experiment to show you the bubbles that they said a crater is looking to be identically mirrored in like a bubble of plasma or whatever. This guy's claiming they move around. I'm not sure I buy that, but the moon itself does spin, so people do get confused. See, all this I'm looking at the sky is, of course, the best globular evidence for a meteorite impact on Earth, right? You heard it in the informational video. The best evidence for why those crater impacts are things from space is the moon, guys. Obviously, look up. Can't you see that that's what those are? We've never seen it happen, right? No human has ever seen it happen ever. There's never been a new one, but we know. We know a billion years ago in the absolute perfect time frame it all happened, and we definitely know we know that, guys, because NASA, dude, NASA has mapped all these asteroids, you stupid flurfs. Why would you guys even question it? Look, let's take a look at all of them.
Hey, you know they're no good, and I know they won't trick me like they did for years and years before, and I'll be asking them to prove their claim. Now things will never be the same.
Look at all these bodies they're tracking for us. Look at the cryptic danger we're in at all times, that all these bodies around us, guys.
Not to mention the entire Oort cloud.
It's like our super nemesis or something. NASA's nemesis.
Stop your lying through your teeth. No, it looks quite flat to me. Appears quite
In 1999, we discovered Ryugu, guys. You don't remember this one? Very important asteroid. We landed small rovers on it and collected samples, guys.
Mr. Street Fighter.
Ryugu, yeah, that's him. That's what his namesake, for sure. Don't forget Ceres in 1801. We only ever, the first asteroid ever found, though we called it a planet until 2006 when we knew that it was definitely an asteroid. I bet we landed a drone on that one too or something. That's how we know.
Oh, shit.
You click on its
Played a little
orbital path
frisbee golf.
instead of its character. Yo, can we see its orbital path instead of the character sheet? Click on the orbital path. Oh, yeah, it's a video. Never mind. I want to see what they would show us for the trajectories they have all these plotted out on.
I mean, we totally can take a side grade and do a roundtable on that. Hold on. Let's get to the NASA asteroid belt. Because that's literally what I was doing with it. It is super fun. Oh, it's like NASA. Oh, it simulates. I thought it was tracking. No. This is tracking. Yeah, it's called Eyes on Asteroids. Here, let me just do a quick switch for this. Change Windows to Eyes on Asteroids. Change this to Eyes on Asteroids. Cool. And now we can go back to our Ryugu boy. All right. Here we go. Oh, wait, hold on. What was the other one? It wasn't Ryugu. It was what?
It doesn't, any of them's fine. Do Ryugu, click orbital path.
You were looking at Series 1.
Yeah. Oh, it doesn't show you the thing. It just okay, my bad.
Look at deviation from circular 0.191. Whoa, guys, this is a super ellipse Keplerian object over here. Oh, yeah, it's perihelion. It's, of course, in AUs, astronomical units, which they just gauge from the optical diameter of the sun of the moon and Mercury, and then just assumed it was the same size, and then based mass off those assumptions, as we all know. But dude, you can take like, so I think you go to like, what's the first asteroid ever found? And it's like, well, good thing that we can check them on all this stuff, right? Like we have our independent backup system where we know these asteroids are actually properly placed in the coordinate system. No, hell no. This is 100% made up nonsense, guys. Right? They know where all these are. If you look at the background of where Earth is, it's like, okay, well, how many are there? Oh, all of them. Okay, no, it's cool. That's cool. That's no big deal.
Is that the Anne Frank asteroid, bro? Shout out to your girl.
Where's it? Oh yeah, huh?
Wow.
Look at that one. Yep.
Sponsored by Bic.
Hey, it was a little before
Because-
its time, Toby, but who cares?
Is that because she wrote her diary in the Bics before Bics were created, or something, or some weird loophole?
Little loophole, yeah.
I think that's an example of retro causality, Toby.
Oh, dude, Mandelu?
Is really an Anne Frank meteor. It was used as a flyby target for the Stardust mission in 2002, Flatman. So, you got to know your lore. I mean, history. Sorry. History. This is history. This is valuable history. Anyway, great eyes on asteroids, dude. You can go in there. You can find out where all of the asteroids are on their wonderful circular, 0.1 to 3 off of circular orbits. All right. Now I can switch back to this.
Yeah, so 0 would be a perfect circle, 1 would be a flat line, right?
Yeah.
And this
0.1.
Okay. All right. Nice.
Yeah, dude, we definitely have those ellipses. That's why we had to create those 2 ephemerises specifically. They were like, no one can know this, so we're gonna hide it by forever entombing the path of the sun and the moon. If you want to know when daytime is, dude, if you want to know when the sun's gonna rise in any time ever, you're gonna have to consult these heliocentric ephemerises where we converted all of the sun and the moon motions for like perpetuity, and they ran a simulation and just ran over and over again. That's what that is. And that's the only 2 ephemerises that are heliocentric. Like, no one needs a heliocentric ephemeris. Nobody needs those coordinates. Everybody needs geocentric, because guess what? That's how you use stuff, right? And it's like, okay, so what was the purpose of putting them? And it's, to perpetuate heliocentricity, obviously. That's the only thing I can come up with.
Yeah.
So anyway, those are the asteroids. Those are not the ones that they say come to Earth and leave us with these giant craters. Oh, wait, let me check. Canva presenter view on my stream. Okay, good to go. Yeah. So this is, I think, the biggest, most famous one. And they're like, yeah, we knew this is the giant crater that hit the Earth. And it's like, okay, but where's the rest of it is the first question. And they're like, it
vaporized.
Exactly.
Mile across and over 500 feet deep.
That's what they say, vaporized.
For the longest time, it was assumed to be a volcanic crater. It wasn't until the 1960s that it was confirmed to have a more celestial, yet just as explosive origin. 50,000 years ago, as woolly mammoths and giant ground sloths wandered these lands,
got a pile in that
a
propaganda.
massive asteroid collided here.
We carbon dated the whole thing, so we know it's a fact, boys.
Equivalent
And then we invented some PIM particles, no relation, and they confirmed that as well.
to more than 20 million tons of TNT.
Turn up your vid volume just a hair there, Shane.
Named simply
Said turn it up.
Yeah, just a little bit.
I don't know if I can.
Meteor Crater. It's the first geologic scar ever confirmed to have been created by a collision from outer space.
The first scar.
Hundreds of other craters have been identified since, but Arizona's remains one of the most spectacular.
We're going to come back to that one in just a minute. But yeah, essentially, like the main position so far is these things coming from space. Because we're in a uniform rotating sphere that's just rotating one direction, causing those biaxial rotations, but also rocketing around the sun at 66,000 miles an hour, rocketing around the solar system at 500,000 miles per hour, solar system rocketing around the galaxy chasing the gigantic black hole, the galactic center, etc. Like all that's happening, and every single asteroid hits perpendicularly.
Hell yeah.
What are the odds of that? It's like, oh, lucky every time. I bet it's the same odds as the good guys winning every war. It's like, oh,
No, that's
100%.
That's when NASA worked out that whole new theory, including the moon, about how because the projectile is moving so fast and it hits something that's so rigid, the impact crater is round no matter what.
Wow. Even though it could hit and glance off and then hit a couple more times and then bounce and then say slide, or does that not work in physics? It's like
Selective gravity yet again.
it bounces and then bounces right out, I guess, like directly out. And then goes back into orbit. I'm trying, man. I got my Glober glasses on or whatever. Yeah, they all look like that, right? So, of course, backwards engineered globularism based on observations would, of course, have to work that into their science. So, well, yeah, all space craters look like that. Duh.
Hit the ground so hard.
Great, and the rest of it went where?
It actually obliterated itself.
Oh, science. Gotta love science.
Back in the early part of last century, Daniel Barringer, he thought that there was actually a full chunk of iron buried underneath that. So he bought the mining rights to this crater. He thought he was going to go down and find $1 billion worth of iron in it, and that's why there is a mining setup right in the middle of the crater. So hopefully we'll get to see that tomorrow. As it turned out, they didn't quite understand the impact physics, and the asteroid essentially obliterated and is found in little pieces all over the area. Some of the larger pieces are actually in the visitor center.
Oh, that's where they were. They're in the visitor
Larger,
center, guys.
like the size of your cat.
It's just spread out, yeah.
Maybe there was a robot that shot it.
I like her theory, honestly.
That's about as plausible, isn't it, dude? Hold on.
I'm pretty sure that robot snaked that guy's iron.
Now, what did she say? I didn't quite hear it.
She said, maybe a robot just shot it. He was like, quiet down, honey. I'm making a video.
Obliterated it.
Oh, a robot shot it and obliterated it, dude. She's a winner, guys. She's a winner. I mean, that's the typical globularist position, right? And you're stupid because you didn't think that robot could obliterate.
What is this thing you call impact physics?
Yeah, they just didn't understand it. They just didn't understand it, Stone. But basically, if you move iron fast enough and hit it against something, it'll disappear forever.
Man, this is going really well. Robot physics, bro. I think all craters are actually robot lasers. So anyway, this is some actual science. We'll just go. This is like a pop stream article, mainstream stuff. If you go here, they say 160 Greek craters. We're gonna map those out. We're gonna find those. And then you're like, oh, well, we know that because why? Oh, the geologic process is notoriously reliable, as we know from Toby's depth into geodynamo model. Someone's echoing me.
Oh no! Sorry.
Oh.
We're good. So the craters today, they know all this, and they know this is from erosion and everything in the beginning that we learned that they would create those tectonic grid patterns that would then be reinforced and then break down on itself. Then it's like, actually, well, I mean, no one's ever observed any of that ever, but we know that it's true. We figured it out.
They got it. We got it sussed.
I love that line. It's like, here's all the stuff we know, and it's like, we've never seen or observed any of this, right? But we know it's true. I mean, look, we know that an average meteorite enters Earth at velocity speed between every 1 second all the time, and it's like, oh my God. Anyway, of all the stuff that they don't know, let's keep in mind the very important context for observing meteors from space, and that is, of course, that this is happening at all times, everywhere, for everyone. We just at all times have this wonderful solar system, right? So all of these are potential impactees, right? These are valid meteors, as they call it, since in their definition, they don't know where they originate. But in their demonstration with illustrations, they see, all these unnamed rocks around this plane. So we're constantly going around them, right? With all of our mass attracting mass gravitational influence, not pulling any of these to us ever. Don't even disturb them, really. Can't figure out how these gravitational masses work with each other, but all of these chilling around here, no impact, bro. Not even a wiggle, right? No ripples. No one's even disturbed. But these guys, man, they're pulling on each other all the time, creating all sorts of crazy orbits, so much so that the math doesn't work. Anyway, all that in mind, right? We're going to observe some star trails. This is technically during a meteor shower. And we're going to look for meteors. We're going to look for meteors coming up from this way, though, right? Because again, they should be coming every which way, right? They should be coming from every which way, not everywhere except from down. The only reason that I can think that they wouldn't come from down, guys, is that down is the same for everyone. And that meteors are a sky fogging phenomenon. So if they never come from the ground because Earth is flat and the sky just exceeds everywhere this way, then you would never see them come up from the ground. But I don't know, maybe we'll see some here. There's some planes coming through and some slow movers, obviously, you can tell. The really quick blinks are supposed meteor flashes, right? This is during a meteor shower. Interestingly, meteor showers always happen in what they call streams of known meteorological activity. They have sporadic meteors, which they have no explanation for, which we're going to go into in depth, and they have streams. And this is occurring in a stream. That's why it's a shower.
Yeah, like the Leonids, for example, every year.
Yep. So they know that it's part of the, let's call it the sun's ecliptical orbit. Oh, is this not playing? That's all right. We're pretty much done with it. Can we go back? Nope. No big deal. It's almost over there anyway. So we never saw one come up, right? Can I move it back? There we go. They come from up here, 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 from up here. I seen in this one video, it came from everywhere. Of course, the sky is rotating, or if you're heliocentrist, of course, the Earth is rotating the other way. Whatever, the sky is rotating. And we have all these omnidirectional blurs and lights coming from as a shower. So they have these little, they call impacts, but all they really are is luminescent. They're illuminations of the sky. Just like we see lights in the sky, this is just, let's call it a luminescent phenomenon. It observes the same storm or meteor storm from a couple different positions too. There you go. But if this is happening, then this should be happening too. Absolutely. And again, the only reason it wouldn't be is if down is down for everyone, and down isn't actually a perpetual tangential plane independent for each person standing on a circle on the surface of a geoid with a gravitational directional requirement to be perpendicular to the direction of gravity. So the geoid that requires perpendicular directional relationship to gravity, because no one knows where down is, because down is always inward due to the centripetal force. So it's always centripetally circulating inward downward force. That's how they know down, and that's why the geoid needs the preferential directional requirement with gravity. So we don't need any of that, or star trails don't need any of that, and meteors apparently they don't need any of that, because they all know where down is the point. Meteors know where the ground is and they don't fall up. Anyway. another one of these bigger craters. Again, this one they built monuments on, right? There's a gift shop in the other one. They say this is from a giant impact from space. It's exactly this size. And yeah, look, it looks just like it exhibits none of the qualities that the informational thing at the beginning said it would. It would have spidering in here from the impact of it rebounding upon itself, right? They said it would have ejecta all around, which no one ever sees, and any of that. And they said this would be spidery and would have caved in on itself to give it this mound in the middle, which we don't see. This is a completely flat basin. So if anything at the beginning was true, this would be a little mound in the middle, resembling something of a volcanic caldera, just because of the way they say the geological phenomenon would have encapsulated it. And then again, why isn't it filled with water? Like they said it would be, or whatever. Oh, wait, no, there's one filled with water. So obviously that's true.
What do we see around the world? These lights we saw in Russia.
We're going to have Eric Dubé give his 2 minutes on it, because I think it's a pretty good explanation, even though it's mostly just for the visuals in the background, as what we're going to explain.
A few years back and Arizona a few weeks ago. What are these?
Well, we've got shooting stars. Like I said, stars aren't actual terra firma. So when you see a light shoot from somewhere to somewhere else, it's simply that. It's simply a light shooting. It's not a rock in outer space coming somewhere.
No, but the ones in Russia that actually broke school windows and it almost felt like an explosion.
Right. And then you've got these ones where you can see mostly from Russia, it seems like, from dashboard cams, you'll see these burning balls of something coming, and they've even crashed windows and something. These, I think, are some sort of military thing that they're shooting to make us believe that meteorites exist, because they're always coming down at an angle like they've been shot from a plane. If meteorites existed and we were on a spinning ball Earth, then meteors should be shooting in every single direction possible, not
Amen, brother.
always from the exact same direction coming down onto the Earth. There should be meteorites that go upwards and ones that go diagonally upwards and ones that go horizontal and every other type of way.
Or vertically downward.
So I'm quite skeptical of meteorites or asteroids or any sort of thing that they claim is up there floating around and comes down here and destroys dinosaurs, their other myth. They like to use their myths in conjunction like that.
Two more questions. No, I'm sorry, finish your statement.
So as far as the Russian ones, I would tend to think those are some sort of military experiment, some sort of weapon or something like this. Because you don't see them all over the world, you just see them there. It seems like it might be something they're working on. And the craters, not sure what those are formed from, but again, not seeing the evidence that they're from rocks falling from the sky. And for shooting
They're also going way too slow.
Around the world, these lights.
Yeah. Yep. But here's one that I would argue maybe is what he was talking about with the weapon thing, just because this.
That's just a sonic boom, right?
It's just a sonic boom. That's true. But where would that have come from? This wonderful thing. I mean,
space. The final frontier, baby.
It would have to be, right? I mean, well, no. I mean, just to try to say, like, what would in nature or anywhere like make that sound and be able to tell me, like, so I'm thinking you have to be accelerated to the speed of sound to break the sound barrier, right? So I'm thinking planes right off the bat is what I was going with that. Right? Something dropped from a plane? No, I mean, maybe this is me.
That's all the earlier angles really looked like they were coming from low, like an airplane, airplane altitudes. The last one was the only one actually to me that looked like less precarious. But
what do we see around the world? These lights that we saw in Russia a few years back and Arizona a few weeks ago. What are these?
Well, we've got shooting stars. Like I said, stars aren't actual terra firma. So when you see a light shoot from somewhere to somewhere else, it's simply that. It's simply a light shooting. It's not a rock in outer space.
That angle.
Somewhere.
No, but the ones in Russia that actually broke school windows.
And that's predominantly what you see.
It almost felt like an explosion.
But then you have real world like effects,
and then you've got
right?
These
like
ones where
I've seen those.
From
That's
Russia,
real. I
like
mean,
from dashboard cams, you'll see
it happened anyway.
Burning balls of something coming, and they've even crashed windows and something. These, I think, are some sort of military thing that they're shooting to make us believe that meteorites exist, because they're always
exactly the same as the other ones too.
Like they've been shot from a plane.
And it's always that angle.
Meteorites existed, and
especially the ones that make noise and damage.
Then meteors should be shooting in every single direction possible, not always from the exact same direction coming down onto the Earth. There should be meteorites that go upwards and ones that go diagonally upwards and ones that go horizontal and every other type of way.
And always in Russia, always on a dash cam.
So I'm quite skeptical of meteorites or asteroids or any sort of thing that they claim is up there floating around and comes down here.
Have you guys seen these before? Because I feel like I've seen one, just like a really glare flash out of nowhere and then nothing happens. And you walk away like, oh, cool.
And
never.
No, you never seen one?
I don't think so.
Nope.
How about like a meteor shower?
Nope, I saw a shooting star once 2 years ago. First time ever.
I mean, this...
And 2 green ones.
Yeah,
destroys
2 green ones.
dinosaurs.
I've
Their other
seen
myth.
a bunch of meteor showers for sure.
Right.
Hot summer
Nice.
nights, certain time of the year, lay under the stars. Count 20 something, 30 something of them in a night sometimes.
Yep. But they like, do they go all the same direction when in the shower? Like if it's a shower, are they all going this way?
They're
No,
random
it's
directions. But of course, like you said, it's like they never look like they're coming up from the horizon.
never this way. Yeah, specifically. And it's like, oh, that would only happen if the ground was down for everyone. It's a very simple observation, right? But it's very powerful. And then we have stuff. So this obviously wasn't caused by a flashy meteorite in the sky. This is one of those filled with water ones. I wanted to put this in because there's a whole section of the Earth, I think, called Crater Lakes, where it's just like hundreds of these, and they claim each one of them as an impact crater that then filled with water. But I mean, if a whole bunch of geysers on the Earth opened up, and then I don't know about that. Yeah, sinkholes would be, I think, very visually similar to what they would claim impact crater is for sure. I wouldn't know how to differentiate the two. But as far as the vast majority, like the stuff that we just saw, I think, and the vast majority of stuff that you would see, it's like, you guys remember the Truman Show, right? You guys all seen the Truman Show? You remember that scene when, well, no, let's just watch it. You guys helped him put all the truth in the movie, and it's like it's not because he's in a dome, right? It's like, no, that's not it. Have you guys looked up like these things?
No, I've never seen that before.
No one's ever seen any of these before.
No.
Oh shit! So if you look up or Google like balls from space, it's a terrestrial phenomenon. They fall all over the place, all countries. They always look like this. No one knows what they are. They're found buried. They're found obscured. They're found. This one was in where dude, I don't know wherever this place is, has left people baffled, right? They all come up with their own explanations for what it is. They find them everywhere. Oh, fragments of a satellite, whatever gas tanks, they're fragments of rockets, they're whatever the hell we want them to be. They find them everywhere, right? Giant balls of metal falling from the sky all over the world. And then governments even are pretending that they don't know what they are too. Like, oh look, Vietnam, mysterious space balls, right? If you just look up any of these, you'll find a ton of pictures. And let's quickly go through a compilation, I think. Sure, bring the kids, make a picnic. Everyone come have a look. A weird thing falls from the sky. Bring the kids, Barbara. Get a picnic. Yeah, bring... People be collecting them. There's so many. It's like, oh, can I trade you a broken one for two...
What? Dude.
Everywhere, dude. They're everywhere. All over. Here, I can do this. We can put down music. Like this guy, like, so, look, a hazmat suit. Like, oh, someone got caught and they had to go pretend to be careful. That's what that is. But these look like, I mean, they look like fireworks to me, dude. They look a lot like...
or like they're releasing some kind of chemical or something.
They got coils. They're all coils. And they got this little air hole thing, which is like what every smoke bomb and firework has. It's like...
Yeah, dude, that's that's what I was looking at. I was like, where have I seen that? Smoke bomb.
Yeah, giant smoke
it's
bomb.
Literal smoke bomb from the sky, bro.
Yep. So that's what I think like those things in Russia would have been. As far as creating a sonic boom and damage, I mean, I don't know if you drop something like that. They give it a little bit of explosive power. I mean, all it did was bust windows, right? It didn't break a building down or blow up an establishment. It was just a little sonic boom and then a window shatterer.
A little sonic boom between friends.
What's a little sonic boom? It's all right, dude. It's just a little space rock.
Machining marks, like they were clearly made.
Those, yeah, yep. And they're everywhere. Like, there's no explanation that's unified for them. They're like, oh, the hypersleep tanks, there's space debris, and it's like everywhere. They always look the same. Right. So there's space debris where there's never been a rocket launch over the jungle. Okay,
that's an impact map I'd like to see.
I'm going to show you what
we got impact maps at the end for everyone. Also, in the Discord, I threw in the RAR file, which has all the slides. Also, on the Canva thing, I put the Canva link for all the slides, presentations, free for you to do that. And also on the database, there's a published tab called Media where I jumped and deposited, posted every slide in case anyone wants any of them. All right. Nice. And this one is, I think, yeah, so this is flat out truth, like kind of most of his video describing meteor showers specifically. And he just takes what we just did, what we just saw, and he just applies. So multiplicity do. He's like, okay, but here's what they do when there's more than one.
Meteors and meteor showers are. There's a difference between the two, but I'm going to show you how they do both of them. The first one I'm going to show you is just a single meteor, or what you think is a meteor, and this is usually how you see it go across the sky. Now, let me show you what this truly is that you're seeing. Now, what I'm showing you right here is leaked photos of some government agencies and some of their agents in hazmat suits going out into this field, collecting this big wiry-looking ball with a hole in the center of it. Now, what this basically is, this is kind of like a coil, like a heater coil. Coil wire harnesses heat, and that's kind of like what this does right here. It harnesses heat. Now, this little hole that you see in the center of it, I'm going to show you what that's for in a second. But like I said, this wire, wrapped wire, harnesses heat, kind of like this right here. Now, this is a car cigarette lighter with a wired coil inside it. And once you plug this in and your negative and your positive connect, it heats that coil up, and you see you get a red glare, fiery red glare, as you can see here. Okay, now this wire, that's what this wire does. It heats up, and that fireball that you see flying across the sky, well, it's eventually got to land somewhere, and they've been found all over the place, Australia, Brazil, and everything. So, like I said, that wire ball, it's like a coil. It harnesses the heat. That's the big fireball that you're seeing go across the sky. Now, the hole that you see in the center of that, right here, as you can see in this photo here, now, that's that whatever this thing is filled with, I'm not sure what they fill these things with, kind of just like fireworks. And this hole that you're seeing, that's where everything's released from, the gases, the smoke, just like you see right here in this smoke bomb. It looks identical, just about. And here's another one here. And like I said, there's all kinds of these things. You guys can look these up. I just put a few in here just to give you an example, give you an idea what these things look like. But anyways, that hole, like I said, releases the gases, chemicals, smoke, whatever is in this thing. That's where it all releases from. And that smoke that you see go across the sky when this thing is flying across the sky, or falling out of the sky, basically, where they're dropping it out of the airplane. But that hose where it's getting its momentum, kind of like a bottle rocket, which all you guys have seen a bottle rocket. Well, same thing. It's got a little hole at the bottom of it, and that's where the flames shoot out at and gives it its momentum, and it shoots across the air. And then what happens when it gets up in the air? It pops, of course. Same thing you see here. It's nothing more than just a big fireworks show to deceive you. That's all it is. So the next time you see one of these flying across the sky,
should be singing highway
just remember,
trucker songs.
it's just a big firework.
He loves his own voice, though. Don't tell him that.
Just a big firework to keep you brainwashed.
Did it for good, buddy.
That's all it is.
Wash. Keep your brain
So,
washed or
anyways,
whatever.
let's move on to what meteor showers really are. Now, these are what they call meteor showers. Now, I'm going to show you how they really do this. Now, this takes...
No, that's actually called a re-entry.
I was like, to be fair, he's not going to be able to recreate the ones that I know that I've seen and that probably Toby has seen, right? Because they're from all over the angles. They're so slight. They're not big enough to be, I don't think, dropped from planes like this. But I feel like they've done this more than once.
Off. Now, I want to show you guys some training footage of how they practice doing it. Now, this is leaked footage also, so I don't...
Oh, no. It's over, I guess. Is it me? No, my internet's good.
No, we hear you.
What happened to Shane?
Some reason.
Rick. Fucker. Let's you guys are funny. See?
That's good.
So now I'm going to show you what you think meteors and meteor showers are.
All right, well, it's a plane.
So now I'm going to show you what you think meteors and meteor showers are. There's a difference.
Oh, man.
Between the two, but I'm going to show you how.
He goes so far through it.
The first one I'm going to show you is just a single meteor, or what you think.
I wonder how I can't
meteor, and this
change
is,
the actual.
how you see it go across the sky.
Can you change the timestamp?
No, like when I started, I can't actually do that.
Oh, that's gross.
How gay is that? Yeah.
Nice
Now,
Canva.
what I'm showing you right here is leaked photos of
right. It's just I feel like
and some of their agents.
I feel like it's right here, but I can't do it. Yeah, that's all right.
It's
We
unfortunate.
can do well.
You use the arrow keys, maybe?
Yeah, I tried all that. All the default hotkeys, I just stabbed blindly right away.
You try Control Shift F12 or no?
What the fuck is that?
I don't know. Just...
I mean, that's not a bad summary so far, but then we're going to get into the academia of it, the papers, what they're studying, what they're looking at, why they have synchronicities, etc. I'm trying to find that video.
Anyone Team Meteor after all this?
Dude, I'll be honest with you. When we first got into this, obviously as a flat earther, I was like, there's no way these are real. And as of right now, I'm still holding the same position. And actually my confidence in that position has been bolstered by about 7,000%. So
you don't think that those could be rocks from the middle of nowhere? I bet they, that's probably how life on Earth started too, right? There was a little bit of fungus on one of those and it hit Earth.
Speedy delivery.
Yep. Dude, the rocks were up there fucking and made us when they landed on Earth, huh?
Man,
that's what they're
because all biological life can survive thousands of degrees of heat on entry. Yeah, that's
because Toby told us about his climate change. I'll tell you guys that not too long ago, I was watching a movie called Contagion, and I 100% believe that all life could have been brought to us by a meteorite or a comet. That was me. Both my hands are up. I was like, yep, that's how we got seeded, boys.
The old space spores.
Yep, space spores got me, dude. I'm like, yeah, that's why we're so special. Still trying to find a way for us to be special. Anyway, if anyone has ever heard Witsit talk about, sporadic meteor impacts, he's talking about this. This is where academia is focused. This is where my position comes in. This is where the new stuff comes in, essentially, right? This is where we're going to make essentially conjectures. They have an ecliptic coordinate system here, and they use radiology. They do all sorts of maps. They do all sorts of testing. There's radio wave observatory in Canada and a whole bunch of other places where they get this data from. This ecliptic map is based on the sun's ecliptic. We're going to get through that. We get to talk about coordinate systems again. Everybody loves those. I know. What do these mean right here? This is the, let's see, we have the north toroidal vortex, the north apex vortex, the south apex, or the south toroidal, and then you have the Helios sun, Helion, antihelios, antisun, right?
Aphelion, I bet.
Maybe. Let's see. Antihelion.
No, you're right. Antihelion. That's trippy.
It's weird, right? It's like, I don't know. Let me get to the next one. Yeah, no, it's that. That's what I thought it was. So this is, I think, the map that our concavers present all the time. A little bit confused, but this is also which it would present, right? And it's based on, well, so this is the data, right? And this is the naming of it: North Apex, North Toroidal, Hellion, Antihelion. And this is the same data displayed a little bit differently. But here's where we come from with like the actual data. So this is what gets presented. Here's, the basic data of, I think this is accuracy. So not accuracy, consistent numbers when they get a migration, right? Because they're trying to pinpoint an accuracy and a number based on other factors, which we'll get to later. This paper, right? Another sporadic meteor. They did a scatter plot, essentially converting that data over here. This is what this is supposed to represent, the averages of the scatter plot. Back to our ecliptic coordinate system, so we can make sense of what the heck we're going to be looking at when they're studying sporadic meteor impacts all over Earth, right? So ecliptic is the same as, say, celestial, except they're going to use the sun's ecliptic as the prime meridian, or let's call that the great bisecting meridian, the horizon line, the one that creates a sphere, the fundamental plane, we'll call it, through that coordinate system, right? And I'm just going to throw up the geocentric coordinate system slide here because it has the other ones. This is just referring to a type, but we have here Cartesian coordinates or spherical. Spherical is the most common, represent geocentric. That's over here. Absolutely. It's how you would see things from an azimuthal projection. It's how you can project stars. It's how the alt-az horizon system works. It's how you would use a sextant and make any sort of arrangement. This right here is how you would use spherical coordinates. Anyway. When we get to this part here, this is again showing you that this is in setting up the alt-az system, right? And this is horizon alt-ascension declination horizon system, which is just the alt-az grid. They chose to set it offset. So the ecliptic coordinate system is essentially this, except this is the bisecting great meridian. Super easy. You can do a basic transform. We'll go over to that. Here's the basic description, right? Coordinate system in which the positions of stars and deep sky objects remain fixed. Essentially, so we are familiar with what is an ECI frame, or that you pair to the static star, or you're just going to say everything moves at the sidereal time, right? The rate at which the stars appear to rotate over us, the 23 hours, 54 minutes or something like that, 56 minutes, 58 minutes, 56 minutes. I think 3 minutes.
I think 54, you nailed it. I think it's 6 minutes off.
There we go. And then solar system objects move relative to that coordinate system. So this is where that meme came in from earlier, right? This is what I was reading when we were going over that. It was like, since they're in orbital motion around the sun, how do you tell? Oh, the background stars are how you tell what you're facing, and then they don't change. So how would they know? So an earthbound observer, right, would just see this coordinate system. It just looks like a spherical coordinate system from you, but it is tilted. To get it tilted, right, you're taking account into this 23.4 degree tilt. Essentially, you're just making the obliquity of the ecliptic your equator. Super easy. And then to translate back and forth, you do some basic trig, because of course, when using coordinate systems, that's how you would transfer back and forth based on angles to the stars, right? Based on a horizon and an angle to a celestial observer that you then use trig to get and compute a distance and a ground position for. So back to our Harvard Radio Survey data here. So they have these marked as A and D and C. These are always pointing at their representative areas, right? So North Toroidal, South Toroidal, Helion, Antihelion. This is just how they do it. This is black and white, but this is some awesome data showing sporadically it's always the same. It's like intermittently consistent or whatever, how you get another oxymoron in there. It's unpredictably constant or whatever. It's like, call them sporadic, right? But they're becoming predictable, and that's why they're writing papers about them all the time. And again, we got ecliptic latitude, longitude over here. We have the sun again, and the apex, and our North Toroidal, where all these right here is where most of it, I think, would seem to take place, North Toroidal. And then you have the Helion and the Antihelion over there. Some of the same data with some color. Sporadic radiant distribution of meteors in the atmosphere, and again, the same points in the same North Toroidal vortex. Now, we're just going to dip real quickly into the primer fields to get some backing for what would happen with high energy double bulb magnetic toroidal fields and what we think happens with the Earth.
To further understand these magnetic fields and validate this new theory, hundreds of experiments were conducted utilizing a vacuum chamber and specially constructed bowl-shaped magnetic field emitters. When 70,000 volts of electricity is applied, the plasma formations that you are now seeing appear. A variety of purging gases were used in these experiments. This includes ordinary air, argon, hydrogen, and helium.
I love this guy, to be honest.
The spacing and orientation of the magnetic field emitters were varied in many ways as well.
He still thinks that like stars are real and space is a vacuum and stuff, but he's on so many right paths.
The magnetic field emitters were suspended on non-conductive, high-strength microfilament line attached to magnetic supports on the inner surface of the vacuum chamber. Then, to hold these supports in place, high-strength magnets were utilized on the outer surface of the vacuum chamber. This arrangement allows for the adjustment of the magnetic field emitters while the experiment is running. The small microfilament support lines also offer minimum disturbance of the plasma flow around the fields and therefore a more realistic experimental result.
Man.
A variety of bowl-shaped magnetic field emitters were utilized in these experiments in order to reveal how changing the geometry of the field emitters affects the matter around them.
Look at him recreating the...
As you can clearly see here, a change of magnetic field emitter geometry also results in a change in the shape of the plasma formation within the vacuum chamber.
Plane of inertia, right? Keeps creating a plane of inertia in the middle.
By adjusting the exposure settings on the camera, notice how increasing the spacing between the magnetic field emitters transforms the shape of the nucleus until finally a disk of plasma forms around the nucleus.
So he's trying to emulate a photon right now.
Also notice the rapid spin of the plasma around the magnetic field emitters, even though the field emitters...
But he's admitted that what he thinks is a photon is actually this double bowl rotating toroidal field of the top and bottom. So he thinks that it's a torus, but it's still a photon and it just exists, and he's reapplying his probability cloud. So he's got the right idea, but he's using the wrong lingo is all.
Are stationary.
And he's a big believer from the micro to the macro, right? So as above, so below. So he's trying to break down the smallest unit, just like an atomist.
You can clearly see how even a single magnetic field emitter controls the shape of the plasma around it. Notice how it confines the plasma to the lower part of the vacuum chamber.
So he thinks that the smallest quantifiable bit of anything is a double toroidal bulb magnet
field. How these fields work to confine matter.
I'll take it.
Right.
Here we see how the plasma spins and flows. In upcoming sections of this video series, we will examine this flow in more detail and its relationship to the spokes in the rings of Saturn and the solar wind.
Yeah, you gotta forgive him that stuff, guys. He makes good comparisons, and you should all watch like all of his series, Primer Fields, on YouTube. When he applies it to things in the sky, what he's doing is he's looking at toroidal nature, and what they say is like, say, look at this nebula, and what it does is that's a double toroidal bulb magnet with ejection jets that they say, and they hide their truth in the sky. And this guy decodes all that truth because he gobbles up that NASA like crazy, and all of the flat earthers ignore it. And wouldn't you know, all the stuff that they hide in the NASA data and the stuff from the sky has relevance for the mechanics and underpinnings and how things work in the world. Who would have thunk it?
chamber and the way in which they shape plasma.
I mean, my argument is pretty much this is going on at all times around Earth, right? We live in this little plane between these opposing magnetic fields, of which we only see and interact with one.
I'd sure love to see his input waveform.
Is what?
His input waveform.
We have seen how glowing rings are formed within the bowl-shaped magnetic fields.
I think he's pretty open with publishing his like experiment stuff and equipment and where he got it and stuff.
Also notice the lifespan of plasma, a merest fraction of a second.
We have also witnessed how the ejection jets are formed.
Yeah, he's got it going for a while though.
Yeah, but he's constantly applying voltage and constantly creating new plasma, right?
Yeah.
It's the old stuff that's disappearing instantly as soon as it's generated.
Is that what's creating all that light plasma? You think that's plasma illumination, not just illumination, electromagnetic radiation from the plasma?
Yeah.
Great.
That's why you can see some of it bleeding to the magnets that are holding it in place.
Right.
Like you can see some of that escape. There's pseudo grounding going on there.
Yep. All right. So that makes perfect sense then. Radial distribution, radial illumination.
Then we have seen how a disk of plasma will form around the equator of the magnetic fields.
Oh, yeah, right.
We have also seen how these formations of plasma rotate at high speeds, even though the field emitters...
Because, I mean, he's pretty much arguing this. This is an atom for him. And I'm like, dude, I'm okay with that, right? We can be friends. We can have a beer. We can hang out. If like he thinks this is the thing that exists in reality, but in reality, this is just nothing, right? This is the plates of inertia, or like the plane what you guys get created.
Yeah,
where
I'm all right with everything about it except for the mass.
Yeah, he does try to attribute it to mass. On the other hand, he has an interesting solve for the double slit experiment like 10 years ago that equates to what we understand it as now. Essentially, he uses these and he lines them up together and he says, oh, with these interfering waves from each one of these overlapping double toroidal fields can interfere with itself constructively and destructively wave interference. And I'm like, well,
yo, no way. That's the best version of how you can explain that. That's awesome.
That's what I'm saying, dude.
Shout out to your boy. That's nuts.
I know you didn't watch the video I sent you. No, I was like, bro, this dude solved the double slit 15 years ago. I was so excited. I was like, dude, I think honestly it's not a bad explanation with his understanding.
Dude, I do remember you sending it to me, and yeah, I definitely didn't watch it.
Yeah, that makes sense. I'm glad that you were excited on and live anyway, though. I would have ruined it if you had read it, so I watched it or whatever.
That was legit a good answer. Like, if that's your model for how it works, like, that's awesome. Self-interference, no problem, bro. That's sick.
Well, he's like, this is a photon, right? And it's like, well, this is the unit of everything, a unit of energy, a small unit, a big unit, micro to the macro, right? We have that. So essentially, he's adopted toroidal fields as this is the fundamental building block of everything. And we're all like, we agree. Yep, we agree. That's definitely what it is. And that's why you have troubles with probability clouds and atoms and you're trying to quantize everything. And it's like, yeah, what if it's just this field? And it's like, nah, has to be a thing. And they're like, put a fucking fake thing in the middle of two fields. And they're like, oh, now we got a business, right? Anyway.
So the mistake with probability clouds is to assume spherical field instead of toroidal. So
exactly.
Classic mistake.
Speaking of that, everybody hates math, but Shane might have some magnetic toroidal math today just for that. Because Stone said it.
I'll take a peek.
We're going to skip to it right now. Anyway.
Change the slide, get it off the screen.
Well, I just wanted to put this here to show it's complicated. right? Like the magnetic toroidal field math is super complicated. We're not gonna go into it. We're just gonna look at it and like goggle. But we're gonna start with this old model. Remember this thing when we were creating, say, a field model?
That was the genesis of it all, dude.
Right? We started with this. We took
What a dog's breakfast, Shane. My God.
Listen, I can say we've come a long way since then, but you know that's a lie. I've only gotten Canva. Anyway, when we're trying to describe the Earth's magnetic field or toroidal field in 3D, I think this was the best representation that I'd saw so far at Lindsay's, right, in his drawing. But then we had an upgrade over here from our girl. I think Patricia made this for me way back when, just to envision the inside view of these double hemispherical toroidal thing, right? So this isn't two equators; it's just the same equator marked from this sort of view. And then if you put, say, like a toroidal field on it, it would resemble that, right? So that's what we're looking at and emulating when we're playing with these, and we're going right to the math. Oh man, a broken slide. So this, you guys can't see that? That's a Ptolemaic generator, man.
Nope, all broken. That one's halfway.
Wow.
All your broken slide are belong to us.
Listen, I guess I can't just copy and paste stuff in there. That's retarded. Whatever, this is the important part. This is the important part. Magnetic field created by a toroid. So, I think my argument, not related to meteors, was that nuclear reactors or whatever is insane power generation when they're breaking down and colliding. I was like, no. They're using toroidal fields around a circle. They're generating this, and it's called a tokamak, right? And this would be the math used to describe it as it travels around the outside, not through, not in, right? Through current traveling through the loop, and then it goes through the directions, the intersection of the perpendicular magnetic and electric fields. Wonderful, wonderful, wonderful stuff.
So for those not, go back just for a sec, Shane, for those not totally up to date on induction science, the B at the top, at the 1 o'clock position, is representing of that blue arrow that's pointing just underneath it. And that is a tangential kind of vector to the B because of the way the coil is oriented around the core material inside of which exists the B field in this case, if it's an air core or a solid core. So the difference between this and a standard cylinder, the way you learn the right hand rule with your hand and the fingers and the thumb sticking out, is that's a cylindrical shape. This is the donut shape of the equivalent. So instead of having a straight axis for the B field, here you have a circular path.
Nice. Of course, on the fly. I put the picture of the tokamak in the chat because it really is a badass slide. I'm kind of bummed that one didn't work. The rest of them is fine.
That is a nice slide, and Senpu would be remiss if he did not see that, so I'm going to put it up on my stream for him.
It's like
a cross-section of a nuclear reactor is one of his favorite things, and I can't let him not see it. So shout out to Senpu if you're there, brother. This one's for you, homie. The old solenoid nuclear reactor.
Yep. Yep. We're going to do like another minute through primer fields, and then we're going to touch on ejection jets, and then we're going to make our wild guesses based upon all of academia and all of Dayton Miller's work and everything that we see.
Now we are going to take a look at the internal flow within this single photon. Again, this would apply to all electromagnetic radiation. The green sphere represents the photon. Here we have the internal energy flow within the fields of the photon, as well as several other views of the photon and its fields.
Like he's using it as particles, a bunch of bouncing around BBs, but the principle is sound.
Chamber experiments.
Interaction of the field.
Are at work in the vacuum chamber.
To me, that just looks like a representation of energy flux density. Lots of little dots, lots of energy.
Now around the core of this photon, we have the bowl-shaped magnetic field emitters.
I mean, that's what it exactly is in reality, right? So he's inadvertently using exactly the
same thing. As we zoom in on the core of our photon, we see the flip ring and the choke ring. Then notice that the incoming particle flow is not just particles. Each particle flowing within the photon's field also has the same bowl-shaped magnetic field structure to it as well.
Eh?
So these flowing
I was just answering B's question about is this a quadrature. I said no, this is a dipole model.
Yeah, no, definitely within the dipole. Because again, this guy's a smack heliocentrist, still believes in atoms. He is the best photon model I've ever seen, but he's still trying to quantify photons, guys. Right?
You're getting fooled by the absence in the middle, the hyperboloid shape. You're seeing a cross section, and so that's why it looks like you're seeing 4 poles, but really it's just. Yeah, no, I just want to make it clear that that's a cross section. That's why it looks kind of crazy.
Yeah, this is one item. So there's only 2. But I mean, he's doing a pretty good job of describing the energy flow through it. And this structure again is based on this, right? And it's based on this, and that's where we do all the models of flat Earth. Like if we were to draw flat Earth, it would be right here, this plane of inertia, right here through these toroidal magnetic fields. The red one, and at this point, we would just be the northern field that we see, right, on the density that we see. And then everyone always looks for the south pole, like out, and it's always been below. That's what we've always thought, as would be necessitated by a double toroidal field model, right? When we have a top and a bottom, just like we have. So we have. If polarity isn't really real, and this model is absence of either, right? It's not tainted. You can say this is positive and negative. You can equally say this is a state of charging and this is a state of discharge. And for the purpose of the diagram, it makes no difference, right? You have 2 opposing states, one seeking the other. Whether it's positive and negative in their misinterpretation of how charges work and how electromagnetism supposedly works, or whether it's this. It's, charging and discharging. This is the best principle to understand. And this guy was able to understand it and use it, right? And you got one more quick video from him before we go try to dangerously apply all of the stuff that we just learned.
Cannot explain the formation we find in Hercules A. So let's take a look at how matter can be ejected by these bowl-shaped magnetic fields.
Yep.
So now I'm going to show you magnetic ejection utilizing the CERN ball. So this one will shoot these magnets, ordinary magnets, about 25 to 30 feet across the room. If I have a large room, I don't have that big a room we're working in right now. So I'm just going to show you what I'll do.
Fun, David LaPont,
down here, and I'll just put it in through the bottom, through the hole in the bottom. A little tricky. It doesn't really want to go in there. It's kind of against it. But then you get it to where it's a balance point, where it doesn't take any energy. But once you push it past that balance point...
That's the threshold between positive or north and south of all the magnets he's got mounted on the outside of that bowl, right?
Yep.
I kind of wanted to cover
knowing
some
that
of the
all matter
mechanics
has a magnetic
of that
component
lab.
to it.
You saw him do. How he produces this thing we are calling plasma in his example in the glass jar and the big hole flare. What you're actually looking there is a spark gap kind of technology. It's post Tesla, and he was the guy. And you'll see this in my first live stream over on my very own channel when I was dealing with Tesla's high voltage transformer and power transmission and stuff like that. I spent a little bit of time on spark gapping and specifically magnetically quenching the spark gap and how that changes the nature of the dynamics, which is why he's going to 70,000 volts in order to initiate a spark gap of that distance through those 2 polar focuses, because he has 2 bowls with all those magnets installed in them. He has 2 polar thresholds between north-south to travel through with a single voltage potential, a single extinguishing of a circuit he's completing via spark gap through these 2 bowls. And he's put something in the way that the spark gaps are hitting, so to speak, on the exact halfway point through their travel from point to point. And that's what's dropping heat onto that material and creating the plasma right there. All he's really doing is creating a hyper-focused path through which the spark gap is operating.
Yeah. He also, like, his video is all about creating energy now. Like when he made this video, he's like, by 2013 we'll be having testing done and everything. And obviously they stopped him hardcore because free energy is still not a thing. But at this point he was like, we got free energy. It'll solve the climate crisis. Like, I've just solved everything, guys. Like, it's brilliant. And it's like, oh yeah, dude. But they're not trying to solve the problems. They're the ones creating the problem. He hasn't figured it out, right? So. Anyway, I mean, he has a great idea for pretty much that post-Tesla toroidal. He's got like his tokamak going. He makes one in one of his videos, and he shows how he's trying to patent it.
You can now see how these incredibly strong,
pretty crazy.
bowl-shaped magnetic fields in space could accelerate.
So he's describing things that he sees in space, but ejection jets and magnetic fields and toroidal fields are all very real, right? We all know and love them. We use them all the time, and particularly if you believe in this model with this coming up from the center, creating everything that we know, then this right here could simply just be a magnetic ejection jet naturally formed by the magnetic toroidal field oscillating in and out over here around all of Earth. That could definitely be that explanation. This is just one of my cooler Black Sun logos over here.
What I want to know is where's the energy coming out of the black hole sun coming from? Where's the mechanism? Where's the energy source? You know what I mean? Not just the radiating body. How did it get to be radiating? That's what I want to know.
Yep. As far as I know right now, magic, but I'm working on it.
No, Lindsay says the same thing in one breath. Oh, it's magic. It's magnetic. It's all in there. We'll cover it a bit. We'll cover it in a bit. Only he never does.
No. Honestly, I have no fucking idea. Right? That's the answer. But we can speculate wildly about it. Like, that would be the question to know. What? What horizontal black sun projection? Why was it horizontal? You mean the Freemason who came out and presented this model? Well, so this is the argument, right? There's a black sun down here as the source of all light and projections that projects through here, through, now I'm just going to argue, through a magnetic expulsion jet all the way through the center, ricocheting or diffracting off of the firmament, or whatever diffractor that would have to be, as we call it, a nice curved charge distributor, which would be necessary for the system that we have in place to have these two come out. And then we have these two, not positive and negative, but two states, right? They're not cathode and diode. We have our dielectric shut and our magnetic moon over here, created from these same positive interactions from this beam, who then destructively interfere only with this one. Right? Anyway, that's what we think it is, right? This all being the source. Now, what creates that? What gives it energy? God knows. I'm going to call it God's astral fist for now.
Cosmic battery.
Cosmic everential, whatever. Cosmic infinity. Yeah, no, it's a good question. I would love to know, but this circle right here is completely... They're like, you know what? You guys have seen enough. Everyone back away. So I would love to get in there and figure out. That'll probably help us figure out what the heck this is, but... And then we're going to take what we learned today from Mr. David LaPont from Barmerfield, and we're just going to apply it to what we think the Earth has, right? So we have our two fields. We have perpendicular working, right? Let's just call this one the one field. This is, say, the dielectric. We'll have that as centripetal convergence, and then centrifugal divergence from the magnetic perpendicularly going into it, to give us something like this as a very crude drawing that is making Stone cringe super hard about force.
Just a quick editor note on this particular frame. I would say that there is no D in centripetal. Just a side note there.
Centripetal. Oh, look at that. What if I just cover it up? There, no one sees it, right?
Oh, you're talking about centripetal?
Yeah, that works. That works.
It's that new physics.
Type of bicycle.
Yeah.
Hold on. Let me screenshot it. All right. This is just a crude illustration of the general force vector, and the only thing I'm trying to show is that they'd be perpendicular. Like this will go in. This is going in and out and down and in. Right. This was different, and it would look something like this. And this is what I think Lindsay's trying to draw all the time with his double. What does he call it?
With his bunt cake soft.
Bunt cake. That's what it is. Yeah, bunt cake pan. That pan thing. We had met our boy Corpus on TikTok, who had a better idea and kind of illustrates it like this. Now it looks like a goofy wire strain, right? So it looks like a goofy wire
lines
frame.
of force. Looks good to me.
Yep. But we got our correct lines of force. We have this tool. This would be the outer ring, and he's correctly denoted what we call the tropics, right? The tropics of creation. The tropics are where everything happens. That's where the sun is. It's where the heat is. It's where the dynamic interface is. It's where tides are reflected perpendicularly when they're not quite over there, right? It's where everything happens.
Check those curvy little arrows near the surface, across the meridian line, going left or right. Yep, those little guys right there. And notice that, although that is also hard to draw, those are not actually flat to the screen. They come in and out of the screen a little bit. Yep. They're a bit of a corkscrew shape, and that's what you're going to find driving the winds. Check that against wind patterns on Earth, and you'll see an absolute similarity.
Right. Well, so this is our boy Corpus. I totally stole his diagram, and he was, I think he was thrilled when he was like, "Oh, cool! Look what you did with it." But still, I looked at it and I was like, "How did you get what was in my head into your video? That's crazy. I'm gonna need to extract that like immediately." When I saw it, anyway, it was like, well, no, obviously it was my idea because it was in my head, right? How did you get my dreams into your video? No, he's definitely got the inner vortex down. We got this. Yeah, I had it. I didn't tell anyone or do anything, but it was mine. He's got the dielectric directly opposing the magnetic. Anyway, when we bring it to what we're going to apply it to quickly, right? We bring it back to our understanding of an atom, or our direct understanding of what we have as toroidal fields, it being the makeup of everything, micro and macro. And we see that this fits in perfectly. And we bring it back one more time to what we had from our academia lads when they were scientifically studying the 4 places where all of the sporadic meteor impact, sporadic means we have no fucking idea, it's random, right? Sporadic meteor radial impacts over here. Bring it back over here. Then we're going to bring it back to our kind of crazy diagram, but that's not quite how it's going to work because, yeah, it's the mess right here. But just because this is the ecliptic, and the ecliptic coordinate system we know isn't 1 for 1, it's at a tilt. So we have to quickly,
So the ecliptic, right? The sun's 23.4 degree tilt. You see how that's at a tilt right there. That is not level, right? If we swing it around biannually, you can see the path that the sun takes. There's the ecliptic.
This tilt is all. That's all we're off. This 23, tilt. Yeah, right here.
Okay.
No, that's the 5.
Oh yeah. Yeah, why is it doing that?
Because Bislin doesn't like you.
Canva, did I pay you this month? Is that what it is? Do you need money? It's like, all right. Anyway, that's all the point. The whole point is that we got to take account for the sun's ecliptic. and if we do that, we get this kind of wild mess. But if we take a back step and we just look at it and we see where do all the sporadic meteors impact actually happen, it seems to be in the tropic gap, and right at the north toroidal vortex would be right at the ejection jet where we see this north toroidal vortex. See if we can get a better picture. Yeah, that's a good one. Let's actually just reconstruct it.
So let's use some of these to create a globy Rorschach test and make Clay take it.
If you see vaginas, you're gay. Just so you know.
A globe shot.
All right, so bringing it back to our boy, we got this, right? Is what we're looking for. If we were to bring it back to what Lindsay was talking about, or our earlier understanding, it would be something like this. All right, you got our north toroidal vortex. If Kat was watching, this would be the hoop or whatever that she always talks about, right? That's the vortex. And then, of course, we have our inner vortex surrounded by our outer. We got the 2 wheels. I know it's coming, guys. We're definitely getting there. Again, back to our ecliptic, or our combined radio survey of all this meteorological phenomenon. And we would see that it actually all happens where? Right there. Right there. So right in the middle of the north, where the ejection jet comes up, right in the top where you'd get particle probably from whatever hitting the firmament, or the diffraction, or wherever the sun and the moon, the generally middle of the top of the vortex makes sense. And then over here, what they called Hellion and Antihelion was where the sun is and not, right? So where the sun is and not.
Yeah.
All right. So we got awesome. So we have our toroidal tropical gap of creation literally being responsible for where everyone sees all meteorological phenomena. And if we were to map it out, I didn't map it out, right? Because we have the right size of Australia, but it would be like over here, over here, over here, and over here. And because 92% of the people live in this northern gap over here and no one even sees the south, then of course they can convince people that they're all coming from everywhere else, right? And if we did it this way, wait, is this a video? There we go. We'll start with what we have as the data, bringing it back to our flat Earth, going for where we know the toroidal vortex field lines are and at and how they interact. Bringing in our data. Oh, wait. Oh, it's right there. It's exactly where you'd expect it. Oh, look, it is right where we look for it out. But actually it is, though. I was looking right in that north toroidal vortex, you know? And it was right where I was looking.
Yeah, it's always in the vortex, isn't it?
Now, for the final piece, then, it's almost like when it coincides with things in the sky, boys, and we're like, well, what is, you know what? I'm going to make a wild guess and say that I'm going to say that it coincides with, say, seasonality, periodicity of the sun, something to do with the sun.
No way.
And it's almost like, oh, it's exactly that, boys. The semi-annual variation in meteor count rate is observable, and they're looking for symmetry, right? And they're like, oh, puzzlingly, it's never that. Oh, man, crazy. It's a minimum at the autumn equinox is not observed. And it's like the maximum count rate is expected to occur in January, and minimum count rate should occur in May to September. Anyway, when they're trying to study all of this together, seasonal. It's always seasonal. Everything in the sky has to do with the sun and the moon dynamic interaction. I'm just going to keep saying that during every presentation. So when you're looking for meteorological radial impacts, you got to be like, well, what season is it and where's the sun? All right, well, that's where you're going to get your plasma sporadic electromagnetic field discharge called, you know, whatever, spiked up through probably an internal ejection jet. So when they land anywhere else, it's like, yeah, the toroidal field moves in a certain way, but it shoots it up, and sometimes it just goes randomly, and people see them in weird spots. But this diurnal cycle observed in July and January, matching it up with what? The sign, good old path of the sun, equation of time, however you're used to seeing it, the sinusoidal wave of the sun. This is the Mercator projection if you were to look at a basic night and day sun, right? And it always lines up. Oh, wait, sporadic radiant meteor distributions do line up? Oh, wait, it's puzzling because we have particle expectations, and they should be the same strength because of our symmetry requirements and presuppositions. But, boys, that symmetry thing from being a sphere, it's like their biggest bane. They never get it. It fucks them every time. Nothing is ever quite symmetrical. Nothing is symmetrical, bro. So here's what we're talking about with the sporadic data when they're plotting the dots. So they get a lot of them, but majorly where the sun is not, north toroidal vortex, south toroidal vortex. So we're literally right over the ecliptic. So wherever the sun is where you're going to see all of this radial distribution impact. Here's a little tidbit for the north toroidal source. Like, who the hell called it that? Oh, in the 60s. Oh, everything, by the way, about meteors came from the 60s and onward. No one before that, they were all geysers. They were all nothing. Nobody even guessed they were giant holes from space. Only in the 60s, weirdly, did they all rename. No. So it's, yeah, it's orbit surveys by Jones and Brown, 93, from the Adelaide Meteor Radar. Right now they have the Harvard Meteorological Radar. That's what we were referencing and using for our data before. But here, the orbital distribution of the north toroidal source. So why do you think they would call it the north toroidal, guys, if they didn't know what the hell they were doing? I mean, it's a weird thing to put in the middle of the sky. North toroidal. And then it's like, oh, is my supposition correct? Well, are they vastly writing papers about it? Sure are. seasonal variations in the North Toroidal sporadic meteorosaurs. So they're like, I bet there's a correlation with seasonality and the sun. And they're like, yep, sure is. Sure is. All the time. All the time. There it is in black and white. Exactly, black and white. And it's going to coincide with the periodicity exactly. So that's why they have solar longitude and solar latitude. They have an ecliptic coordinate system, which is this weird ellipsoid looking thing. And they're giving solar longitude and latitude. So they're just basing the whole thing on the sun. The sun is the prime meridian again. So that's why this doesn't look like it's off, but it's equidistant and it's coinciding with the seasonality and all of the observations from Earth, right? So everything we've ever seen is right in these patterns, right in this middle. No, this is from a published paper. And again, when we started with, dude, no one has ever observed an impact crater in nature. No one. But they know everything about it. Don't you worry. And I think we just got a couple of videos. Yeah, we're almost done. Go through the position one more time, I think. For Shane's position on what Shane argues sporadic meteor radial distributions are. Damn. Yeah, I convinced myself looking at that. I mean, thankful for the plasma field, dude. This we just live in this giant a plasma field for the magnetic fields that are creating our dielectric plane of inertia that we can live on at all times. And thank God the tumultuous outside of inverse and perpendicular relationship of magnetic and dielectric keep us alive based on their tumultuous nature and keeping us stable and level. Hey.
So this happened from asteroids, right?
And then a quick summary of this other dude making the same points. Gotta love TikTok.
At least that's what we've been programmed to believe. But what if I told you that this was a phenomenon that has happened from below and not something that fell from above?
I'm gonna warn you, this guy says geezers, which I think is super gay. But anyway. Oh no, I ruined it. No, he says geezers. It's geezers.
Right? At least that's what we've been programmed to believe. But what if I told you that this was a phenomenon that has happened from below and not something that fell from above? Isn't it interesting that what we have thought to be craters look a lot like geysers? Now let's compare both side by side.
Yeah, it looks like a geyser to me.
That's a Canadian geyser right there.
Pretty similar, right? Now,
Them old geysers are so shallow.
The impact of meteors, that no such thing is ever by or around these craters. Check out what Genesis 7:11 says. It says, in the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. Are you following me? God opened up the windows of heaven, and water came out through the firmament, and also it sprung up from the ground. Think about these as giant geysers that erupted at the time of the
I was thinking, now I'm not.
Yeah.
Who are serving his purpose are trying to cover up the fact that God has judged the world before by a flood. And as 2 Peter says, that these scoffers are willingly ignorant.
I'm gonna go with this dude.
Yeah, God used geezers to judge us. I got it. Checks out.
Geez.
They deny the flood because if that happened, then so will his judgment by fire later come to pass.
Hear me out though, right? Here's that map that they referenced. So this is the map we started with, and they were like, "Oh, we know 200 giant impact craters all over Earth," and they were like, "But we got 20,000 on the moon, right?" And we're like, "Okay, great." But here's the map, and honestly, I couldn't think of what to do with this. Well, no, I could. I did a couple things. Here's 3 more. They're all identical. Don't get excited. There's definitely only one map of all of this data, but the thing to correlate it with, I mean, so if these were supposed meteor craters, what would you guys want to see it like overlaid with? What would you want to look for?
The model from earlier with the northern apex, or the northern toroid and the southern one.
Right. But I mean, like, you remember when I did the tides and I had like 57 map overlays of like amphidromic points, tides, magnetic field, magnetic flux, this thing, and like topography, fault lines. Like, what do we think would line up with comets? Yeah, we can't hear you, dude. Grim? Yeah, were you talking to your shoe? Yeah, that's better. What do you got? That's crazy. No, they've never found. Oh, the plasma, what the bubbles, Yeah. Yeah, I gotcha. I'm gonna find him out because I was looking for that video to put in this presentation actually to find out. Like so the other emulation thing that's like, look how this plasma bubbles and forms the things that you think are impact craters. Anyway, in regards to the geezers, boys, the geezers coming up from the deeps. The only thing that I was thinking when looking at these supposed impact crater maps was like, all right, but if you were gonna flood the Earth, like okay, for 1 second, if you were gonna flood the Earth, where would you put these emergency fucking from the ground sprout up geysers to make sure that all the ground got flooded? What do you guys think? So high ground, valleys, it's surrounded by topography, isolated, desert. So if you have to flood, the Earth, I'm just saying, if all of these are impact craters, no, that's ridiculous. How about if they're all what if they're literally these? No, just like they say that these are the big ones. So these are the big craters. These could just be geysers, right? All the big giant craters that they say are impacts. Well, then it's like the placement of all of these impact craters would merely be where I would put them all if I was going to flood the Earth. Is all I'm saying. As my final guess. Sinkholes exist, and so do geysers. Well, like 42% of them fill with water mysteriously, so that's a pretty good indicator, dude. Yeah, rain does happen. Bro, you're like, you can't even be heard.
Yeah, try again, G.
Yeah, plus you have inferior mic, so if a mosquito farts, like it just tunes you out. It's Discord. Well, maybe I don't know. I mean, that was just my last guess. I was looking at maps to overlay, and I didn't really try a bunch, and I will try them all essentially. But the elevation made a lot of sense to me, especially if I'm going to argue that maybe they were geysers, and I'm like, well, their placement is weirdly coincidental to that. Yeah, I was doing in the background. I was making for the video to show the exact placement again, because I got nothing else. That's pretty much the end of my one. I guess that went pretty long, an hour and 42 minutes on Meteors. What do you guys think?
I think that was awesome. Except the only thing is, right, like you showed us the meteors, those spheres. So obviously those are balls from space, and your whole presentation's crazy.
So I meant to differentiate that, right? The balls from space are little ones that we see all over the place. You can definitely find those, but the ones that are sporadic that they study, like the flashy ones, right?
I mean, it's it's pretty insane. You think about the story that we are told, the grand narrative of like the space rocks and the way that they smash into the earth all the time, and then really there should be like no rhyme or reason to it. It should just happen. I mean, I guess there could be some rhythm to it with the asteroid belts or whatever, as you kind of laid out to an extent, but like it should just be things pelting the earth. And the narrative is that there are literal objects that hit the ground that cause these craters. We don't see any of the actual literal objects. And the only times that they actually do find literal objects, they're like extremely man-made looking. Like I don't know, man. This is not a narrative I would ever want to have to defend.
You guys haven't really seen magic balls from space before? I was like, I'm just bringing up old stuff for you guys.
If ball falls from space, that must mean that it landed on a ball. Right?
That's all they got. That's it. That's what we've actually seen fall from the sky are these things. These are more real than space rocks.
Very real, everywhere.
NASA puts up figures, guys.
Now the Peruvians are in on it.
I don't know. I'm a cosmographer. I'm talking about the actual sky compared with the actual ground. You guys are all fucking retarded. No, cartographers are stupid. I'm a cosmographer. You should have seen when I was talking about the black sun, like everybody knew it. It's like this isn't you guys' favorite model that you study and know everything about. What? But no, it's the black sun, man. Come on.
I mean, I'll just say this: like, I don't know if that was a proper steel man of the argument, but you know, as far as I'm concerned, you didn't leave anything out. It's just kind of hilarious how insanely out there that narrative is, and like, I don't know, man. I would like to hear someone steel man it and like try and sell me on space rocks. But I don't think I'm gonna find anyone to do it.
It's like
it starts with NASA. No, the first thing they put up is the figures, guys. They're talking about daily figures of like hundreds of things that are coming down allegedly, and the total mass daily is to the tune of 4 metric tons of detritus per day hitting the Earth from space.
Is Stone the audio engineer low for anyone else?
Super low, yeah.
Oh, am I low? Shit. Oh man, it's got to be the wrong input again. Let me check that.
Yeah, maybe let's put a call out to all the specialists out there. Anybody who wants to
I mean, at this point,
you know,
we're just looking at the data and we're just making a better determination. It's like, does anything else that makes more sense correlate with that more? And it's like, yep, sure does. So you guys have just been like before when you were the only game in town with your crazy explanation, that's where you at. But now there's like a reasonable alternative. So, you know, I don't know.
Well, yeah, you know, Bull Knight tried to bring forward some very interesting or he did bring forward some very interesting information in that they can bounce radio waves off of meteor showers. So, I mean, I think he saw that as like an evidence of the mainstream theory. I saw that as like yeah, definitely a bunch of rocks up there, huh?
I was like, that's cool. I don't disagree that they can at all. I think that'd be neat.
Like
that's why I like Bull Knight.
Yeah, it indicates some other kind of phenomena just as well, or better, more so than space rocks.
I don't know. If the shoe fits, it might be a space rock.
Yeah, it's awesome.
Thanks, dudes.
Great Prezi.
We're trying to do more of a roundtable where people have opinions and participate. And as opposed to, it's like, you guys still there? Did you listen to the last 18 things I said? Or do I? I'll just keep going, bro. I'll plow through until my brain stops. Like, here we go. You guys going with me? Yep. On cue. Here we go.
Look, welcome to school.
Yo, Toby, you want to close this out?
Nice, dude.
Practice required.
Hello?
All right. Thank you, Flatman. Thanks everyone for listening in. This has been another Aether Cosmology Roundtable. Check us out next week, next Monday for more reading, and then next Tuesday for another Aether Roundtable. I think on climate change. So we'll talk to you all then. Until there,
next week. Next
next
week we have if you guys said that already. We have 16 emergency landings.
So I actually don't know what's up with that. So go ahead.
So Ruhif next week, and then climate change the following.
Oh, all right. So
right, we're gonna do 16 emergency landings that prove flat Earth, or do they? Fun.